Now, we want to start this section, and I want you to listen very well, and you'll understand everything we are doing. Today, we want to talk about the calculation aspect of vectors. We have actually talked about introduction of vector, where we give the definition of vectors and give examples of vectors, a lot of them. And we also cited a lot of questions on that have been set on maybe WAEC and JAM level for examples on vectors and scalars. And we actually did a lot. But today, we'll be looking at some basics about vectors and scalars calculation. Now, majorly, we are going to major on vector. Now, if you have what a force, let's say they call it F1, we have another force F2 moving in the same direction. It tells me that the angle between them is 0 degree. And if the angle between them is 0 degree, it means that they are moving in the same direction. What is the net force? The net force will now be equal to what? F1 plus what? F2. According to vectors, if two vectors are moving in the same direction, force is a vector. It means that you have to add them together to get the total force, which is the resultant force. In other words, we can call it the resultant force. Now, and the angle between them, between F1 and F2 is 0 degree. 0 degree. So now we understand that one now. Now, what if they are moving in opposite direction? Let's say case 2. Let's call this one case 1. Case 2. Let's say they are moving in opposite direction. Let's call this one F1 and this one F2. Now, if they are moving in opposite direction, what is the resultant force? The resultant force will favor the higher, magnitude. Higher magnitude of force among the two of them. Let's say, F1 greater than F2, for instance. Let's assume that here. Now, and don't forget, for them to be moving in opposite direction means that the angle between what? The angle between them, between the F1 and F2 is what? 180 degree. That means for them to be moving opposite direction. So the resultant force now will not be what? F1 minus F2. That means that where will the resultant follow? It will follow this direction. That means the resultant force will favor the left. That means the direction of F1 because it's bigger. Where will the resultant force favor here? It favor the right hand side because both are moving in the right hand direction. Now, so this is the resultant force for two vectors moving in opposite direction. Don't forget, when two vectors are moving in opposite direction, you subtract. But when they are moving in the same direction, you add. Then another interesting part that we need to understand here is that if they are, that is case, let's call this one, this case 2. This case 1. If they are moving at an angle 90 degree to each other, let's say one is moving like this to the east, then the other one to the north, for instance. Let's call this one F2. Let's call this one F1. The angle between them is 90. Now, how do we calculate the resultant force? The resultant force will be a common line drawn from the meeting point of the two of them, and that point of right angle. This is the resultant force. And how do we get the resultant force? Let's close the triangle. We are going to use Pythagoras theorem, knowing fully well that we know this place is as the hypotenuse side. Then this side is the opposite. If this one is the direction of the resultant, so this one is like opposite to it, which is your F2. Because here is equal to this place, and here is F1, which is F1 here. Now, if I want to resolve this now using Pythagoras theorem, it will now be R squared equal to what? F1 squared plus F2 squared. Then what do we have to make our resultant formula? Resultant will now become square root of what? F1 plus what? F2. This one is case 3. Now, in this case, how do we get direction? Direction is what? To get the direction, how far? You use what trig ratio, which is what tan alpha equal to what f2 over f what 1. That is what opposite over what adjacent. So that's what we are using now. And don't forget, this particular topic also will reflect in A level. So don't forget that. Now, if you have what this, somebody can say F2 is equivalent to force along the x-axis. That means what? The vertical force. While F1 is what called Fx, which is what? The horizontal force. Horizontal force. Now, since we have gotten the vertical and horizontal force, I mean, this one can be Fy over Fx. In the case, that means F2 can be Fy, F1 will be what? Fx, F1 will be Fx. Now, but what about a case where this angle between the two what vectors or the two forces, as the case may not be equal to 90, either greater than 90 or less than 90. Let's look at the case of less than 90. Let's look at the case of less than 90. Now let's have something like the less than F2, this F1. Now let's say the angle between them is theta, and theta is less than 90. Don't forget, this is case 4. Let's call this one case 4. Now in this case now, this is forming a parallelogram. Let me complete the parallelogram. Let me just do what? Complete the parallelogram. If I complete the parallelogram now it says that what? According to parallelogram law, it says that when what two forces represented with their adjacent side having magnitude and what and direction, the resultant force must be drawn from the what? From the common point. So this is the resultant force now that will be drawn at the common point. The common point means the meeting point. So this is the resultant force. You must not draw it from any other place. So that is it. So this is what F1, as the case may be, is F2, and this is the resultant. Then this will be the what? The direction. After you have completed the parallelogram, please take note of that. After you have completed the parallelogram. Now, having done that, let me extend this. Don't forget that this angle here is corresponded to this angle. So here is what? Theta, corresponding angle. If there is theta, here will be theta. Now, that means here will be what? 180 minus theta. Don't forget, this is a straight line. An angle on a straight line is 180. If you remove what theta from 180, we are going to have this as 180 minus theta. Now, for us to find R using what? Parallelogram law. This is equal to what? Don't forget, parallelogram, opposite sides are equal. This is equal to this. So here is also what? F2. So let's consider A, let's consider B, and let's consider C. So ABC is equal to what? A triangle rather. Then we have two sides and one included angle. So we look something that look like what? Cosine rule, which is what? F1 square plus what? F2 square minus 2F1 F2 cos what? 180 minus theta. So that's what I want to use now. So once we do that now, what do we do to find R? R becomes what? Square root of what? F1 square plus F2 square minus 2F1 F2 cos what? 180 minus theta. So this is the resultant force. And how do we get the direction? To get the direction, you can just use what? Make use of cosine rule, then sine rule rather. So what is sine rule saying? Just say it that if you draw the diagram out, this is what if you draw it out, is a rough sketch of A, B, C. This one is 180 minus theta. Then this R, this F1, and this F2. You will discover that what we can, yes, alpha, which is direction of the resultant. So that means we are going to say F2 over sine alpha using sine rule. Now this one, don't forget this angle is facing this, so it now be F2 over sine of this angle. Then R is facing what? 180 minus theta. So R over sine 180 minus theta. Don't forget, sine 180 minus theta is equal to sine theta. So we can write it as F2 over sine alpha equal to R over sine theta. Then from here, you can get your alpha, which is the direction. So these are the basic things we need to comprehend when doing what? We are still going to look at other cases in part 4. This part 3. So we want to take question now with the little we have learned and all that. But before I go to the question squarely, don't forget basically that if you want to resolve vectors, let's say we have what? Basically, and I need to teach you this. Now, if you want to resolve, like R is the resultant, making an angle to the what? To the horizontal. This is the horizontal, this is vertical. Now, since the angle is lying on the x-axis, the x-axis is cost. You will not be costing that much. Now, this x-axis is cost. When I mean by cost, that means that you want to resolve, it will not be what? R cos theta. While the other side that is open will not be what? R sin theta. You can also use SOHCAHTOA by what calling this one y, here x. And then when you resolve, this is x component of what? Of R that you have resolved. So if you want to resolve, if you call this one ry and you call this one rx, if you use SOHCAHTOA also by saying cos theta equal to this r is equal to what? Adjacent over hypotenuse. What we are going to have is what? This adjacent, because the angle is sitting on that. Then this is the hypotenuse, which is the longest side, or the side facing the what? The 90 degree. So what we are going to do is because we have rs equal to what? R cos theta. Then if you do that for what? For the vertical, we are going to have what? R sin theta. That is how to resolve. Now let me extend this. Now if you let me have the angle here, please take note of this. Let me have it here. Let me have another theta here. Let me call this one R2. Let's call this one R1. So R1, another. If I want to resolve this one now, how do I resolve it? Because the angle is what? Inclined to this vertical. Don't forget, the angle is inclined, is closing up on the what? On the vertical. What we do? We say here will not be what? R2 what? Cos theta. But don't forget to put the sign, because this is what? Negative y-axis. Why here will not be what? R2 sin theta. Why? Because here is open. Now, that is to say that R2 cos theta is included because the angle is actually what? The resultant here is inclined to the what? To the vertical. So it will take cos. So please, these are the basic things we need to understand when resolve. This is what we call resolution of vectors. Resolution of vector. This one can carry minus, this one can carry minus, because here is negative x, here is positive x, here is positive y. Another thing again you have to know, lastly, before I go into question, is this one. If I give you a diagram like this, triangular vector, something like this, I call this arrow is what? Let's say R. Let's call this one P. Let's call this one Q, for instance. Now look at the arrow. When two vectors are moving in the same direction, what do? You add. We have done that before. Now, how do you know when two vectors are moving in the same direction? Look at this arrow. This is triangle. Now, this arrow now is showing that, look at it, follow my hand, that is going the same direction with P. So P, vector P and what? Vector Q are what? Moving in what? In the same direction. So as such, since they are moving in the same direction, you are going to have what? Add them together, P plus Q. Now look at vector R. Vector R is going against the two of them. That means it's going, that means these ones are going in the same direction now. We have what? Add them together to produce one single one. Now look at this. This one is going in opposite direction to what? Look at the arrow against the two direction. So that means R is going like this. Is going opposite to the direction. And what did we say concerning when you have two vectors moving in opposite direction? We subtract. So this application P plus Q minus R is equal to 0. Don't forget the sum of vectors in a triangle must be equal to 0. Please take note of that. The sum of the total sum of vectors or the algebraic sum of vectors in a triangle must be equal to what? 0. Therefore, R vector will be equal to what? Synonymously equal to what? P plus what? Vector Q. So this is a relationship between what? Relationship between P, Q, and vector R. So please take note of this basic thing that we have to have taught you how to what? Resolve and how to find vector summation in a triangle. Now let us take question now this time around. We want to look at question. So it is time for us to what? To start solving. So and I want you to follow